All right, thanks. So I'm sure lots of you have heard me speak before, and particularly on source water protection. So I'm going to try to highlight some of the things that we're doing that are new for this year. We've had this program in place since the early 90s. So we, with some help to Chartered Limited, started the North Saskatchewan Watershed Alliance much before Water for Life was in place, and much before I was working at EPCOR. So I've almost been there 10 years now. But the idea is that we knew a long time ago that from a drinking water provider perspective, managing our upstream source water, including every piece of land upstream, which is included in our source, not the headwaters, but every part of land that drains into the North Saskatchewan upstream, we consider part of our source water protection area. We realized quickly that the most effective and most efficient way to manage our source waters was to make sure that we understood the quality and quantity and what the drivers of that quality and quantity were in the basin. So hence that program started. So I think Vanessa talked a little bit about the history of the North Saskatchewan River and how dirty it really was. So we know that the first water quality monitoring actually occurred in the 1950s, and the water quality in that time was quite poor. And I heard someone talk a little bit about, well, does the public know this? Is this out there? Alberta Environment has published a lot of really good reports from this time period in the 60s, 80s, and those reports are publicly available, looking at the water quality data. As well, through the Way We Green program, I published a report as part of that looks at the whole history of water quality in the North Saskatchewan River. And that's publicly available. You can Google it. We're all capable of that. So there is a responsibility to make sure that information is available, but there's also a responsibility for each of us to look for that information because it is there. So if you want to know the whole history of water quality in the North Saskatchewan River from a greater perspective over the last 100 years, it's there for you to find and read. So we know, and we've heard already today from our previous presenters, that there are multiple competing land uses and also land planning initiatives in the basin, whether it's from the Devon to Pecan Reach, whether it's the entire headwaters reach, whether it's from the headwaters area all the way to the border. There are multiple land use planning initiatives underway, and they're not always talking to each other, and they're not always aligned. That work on that alignment is something that we at EPCOR are hoping to facilitate and have spent a long time trying to facilitate, at least by being involved and aware and participating on each of these initiatives as they come along. And if you're in water resource planning for long enough, which looks like some of you have been, you realize that there are there's no insult there. You can see a lot of things come and go. You've seen Water for Life come, you haven't seen it go yet, but you've seen other watershed initiatives, other basin initiatives over time come and go. And it's really important to stay engaged and to realize that we're working towards that same goal, however slow it may be. We found at EPCOR that integration with existing frameworks, not rewriting the book on them, not rewriting a report, is the best way. So being involved in each of these organizations. Whether or not we think that we are reinventing the wheel, it's still important to be involved. So that's our sort of approach to source water protection planning, and that's the crux of my talk, is how we get involved in each of those aspects. And we do that through our watershed protection program. So I know my talk is on source water protection, but when we talk about source water, we've really moved away from that concept of, well, everything upstream, but we don't care downstream. It's a holistic approach to watershed management. We're also responsible for the Gold Bar wastewater treatment plant, so we're responsible for protecting the river as it moves downstream to downstream users who also have source water initiatives, whether it's for drinking water or for irrigation or for other uses. Source water implies that you're using it for some sort of use, and it doesn't always have to be drinking water. And so we have a responsibility to ensure that source water is maintained throughout the basin, all the way as water moves north, not just in this province. So I'm sure you're aware we have two water treatment plants in the Edmonton area, so the E.L. Smith water treatment plant and the Rossdale water treatment plant. When E.L. Smith was first commissioned, there wasn't a lot of land use upstream, so it was considered largely pristine. that area of development, as you've seen if you've driven from to the airport recently, is a big area of growth for Edmonton, and that includes a lot of urban development upstream of E.L. Smith. And so as Edmonton grows, we'll continue to have to deal with more non-point source pollution from stormwater and those sorts of inputs there. We have the Gold Bar wastewater treatment plant, again, the capital region. So I recently had the pleasure of hearing our Minister of Environment speak on water. And what she said really struck me because she described all the water bodies in Alberta. She said, we have 20,000 square kilometers of water in water bodies. And what really struck me was we really have the entire province of Alberta that drains in, and it's one ecological unit, and it can't be separated. And I think that from our perspective, every time I give a talk, I really have this slide that it is a one ecological unit. A lake doesn't exist as a water body, it exists as its watershed. The North Saskatchewan River doesn't exist as a stream or a channel, it exists as its watershed. So everything we do in that landscape really does matter. And so upstream of Edmonton, 28,000 square kilometers affects the water that we have at Edmonton and at our drinking water. So it's just really important, and I know that you all know that, but never forget that when we talk about the North Saskatchewan River, it's not the channel of the river. It's that entire ecological unit which has hydrological function that affects water quality and functioning, including the riparian areas, including the wetlands, including all the impervious surfaces that we've created. So 1.2 million people and growing in the basin, mostly focused in the Edmonton area. 2 hydroelectrical reservoirs, 3 coal-fired power plants, soon to be 2. We have a large petrochemical sector. There's a lot of land uses in the watershed. And we have a lot of watershed management approaches at different scales. So you're probably involved in lots of them. Under Water for Life, you may be involved in the Alberta Water Council. You may sat on committees. You may be involved in the WPACs, the NSWA, on various committees there. And in those sub-basin plans, whether it's the industrial heartland plans, which could be considered a sub-basin plan, you could be working under the cumulative effects management framework, under the land use framework. You could be working at an approvals level all the way over on the regulations and standards. And I put this slide up to just really show you that there are multiple competing land planners and initiatives that aren't always integrated and tied together. So you could be working on a water quality management framework that sets water quality objectives for the main stem of the river, and then have no idea that there might be another group, a headwaters group, that is also working on setting water quality objectives and land use planning at the municipal level. And so that's where that integration becomes so important as we move through this. One such aspect is this multi-barrier approach to drinking water. So I'm bringing it back to drinking water specifically. So one of the approaches is that source water protection aspect. And Nicola will talk a little bit after me about some of the other aspects of this multi-barrier approach to reliable drinking water, but this source water protection aspect. So that source water protection aspect is all that watershed planning, right? Because it's that 28,000 kilometers squared upstream, and it's that downstream area as well, which is, almost 60,000. So in order to do source water protection, we have to do all the things that we've talked about already today. We have to monitor water quality. We have to understand what those drivers of water quality and quantity are in a changing climate. We have to understand the inventory of land use. So we talk about some of the point sources, some of those industrial dischargers. We have a lot of non-point source contributions. We have all sorts of anything that you would have on the land, big or small, cumulatively impacts that water quality. So we have to understand what's happening. So at my desk, I'm constantly looking at pipeline layers. I'm looking at growth and development of all our urban centers. I'm looking at agricultural land use, how that's changing, and taking all that information together and trying to assess what the changing risks to source water might be. And then once we have that idea, we look at how we've controlled that from a water treatment perspective. We talked a little bit about sediment. Sediment is less of an issue from a treatment perspective because we have controls in place. that really help eliminate that sediment before it gets into your tap. Things that we don't have in place or we've identified are spills, a hydrocarbon spill in the river. If we're not aware of that and it gets into our treatment plant, it can have a big effect on our ability to treat that water. So it becomes a high risk because we don't have treatment in place at the time. So how do we manage that risk? And then the watershed management plan. So once you know all this stuff, how do you develop a watershed management plan? We have no ability to control growth or what occurs on the landscape. That's up to individual municipalities, that's up to the government in green areas. And so how we influence that is helping to address those risks, at least letting people know what those risks from a drinking water perspective are so that we can address them. So there's lots of source water protection policy, and I really put this in just so you can have it after. But there's not really an Alberta source water protection guideline or standard that tells us this is how we do source water protection. And it makes sense that there's not, because really it's integrating with all the existing frameworks. Under Water for Life, safe, secure drinking water is one of the goals. So of course, it makes sense intuitively that source water protection would be included in there. But it's not clear how that process occurs. There is an American Water Works Association standard and guidelines for how you do source water protection planning. And really what it says is integrate with the current frameworks that are occurring in your particular area. So if your source water protection area is a lake, you would use lake watershed management planning frameworks to help address your source water protection goals, where you'd also be addressing maybe fish goals or algal goals. You'd also be looking at it from a drinking water perspective, or whatever your water use is. So EPCOR's approach is kind of a four-pillar approach, so that integrating in with watershed management, implementation, so we do on-the-ground implementation, or at least fund organizations that do that sort of work. So that includes BMPs, whether they're urban BMPs or agricultural BMPs, to try to reduce on-the-ground actual things that are changing. Research and monitoring is probably the largest pillar that we work on. So that's the gathering that scientific data, water quality data, water quantity data, climate change research, integrating in with other researchers who are doing that work and being tied in to ensure that we know what the quality and quantity is now, and we can help predict that in the future so that we can do infrastructure changes as needed. And then education and awareness. And whose responsibility is it for education awareness? I think it's all of ours in each of our areas to have information go out and to listen to information coming in. So I'm just going to go quickly through each of those pillars, and that's essentially my talk, just so you know kind of what EPCOR is doing in each of these areas. So we have an EPCOR source water protection plan. It's a 100-page document that describes the watershed in terms of quality and quantity upstream of Edmonton. It has all the land use GIS layers. It's got all the water quality data collected by Alberta Environment, collected by EPCOR, collected by Agriculture Canada. Everything that's been collected is summarized in that document. So if you really want a comprehensive understanding of what's happening upstream of Edmonton, if you read that document, you will become a little bit better informed in terms of the science around that, should you desire that. It also outlines some of the frameworks of planning. So it talks about the North Saskatchewan Watershed Alliance, what the mandate and what the role is, and then what EPCOR's role is in that. How EPCOR's role plays out in the Industrial Heartland Watershed Management Framework, how we work with the Alberta Water Council, the regional plan for the North Saskatchewan River, how we've been involved, and then how we get involved at the local level in the City of Edmonton for the Way We Green plan, including the River for Life initiative, which Ross will be talking to in the last talk of the day. So we've talked a lot today, or I haven't, but other people have talked a lot today about those water quality objectives. And I think for the NSWA, one of the largest and most productive things I think that the NSWA has done is set water quality objectives, or propose water quality objectives, to start the conversation for how we want the river to look in the future. And it really was the start of no further degradation to water quality. And when you start by setting a limit, whatever that limit is, and we know that all our land use affects water quality, we know that when we grow or we change that land use, we have to do it in a way that's not going to impact that water quality. in a negative way. So that means that now when we're doing municipal planning, we have a line to hold, whether it's up in our headwaters or whether it's within the city of Edmonton, we have that starting line to hold. Those water quality objectives have changed, they've morphed, the industrial heartland has developed some, the province has developed some, looking at whether it's 90 percentile or 99th percentile, doesn't matter. The concept is that we're holding some sort of line and some sort of limit. And from EPCOR's perspective, knowing that we can start to design our facilities knowing that that water quality is unlikely to change if we're committed to that at a landscape level. So we have our source water protection plan, which I talked about. It's updated every 3 years. The next update is in December. Implementation, we work with Clearwater County on some of their programs, including their Sasquatch program, and then other BMPs, off-site watering for cattle, those sorts of activities. We support the Alberta Low Impact Development Partnership for urban, for controlling urban runoff, really. And then we have a pilot project on Strawberry Creek. Implementation examples, just really on the ground stuff. So many of you have probably worked in water for a long time. And if you could think about what you've actually done or what you've actually seen change on the landscape in the time that you've worked on water, it may not be a lot. We have a tendency to continue to do business as usual because change is difficult and linking land use to water quality is difficult. So when we're starting to make those decisions on the landscape, unless you're working on the ground and boots on the ground and actually restoring a specific area, a specific riparian area, it's a lot of policy, it's a lot of planning, and what really starts to hit, the rubber hits the road is that implementation. So that focus on implementation. And I know Sherry Claire is probably going to talk a little bit about that from a riparian perspective, some of the tools that we can actually start to use to implement things on the ground. And there's a lot of great examples of groups that are doing that. Alice is a great example of what's actually happening on the ground. But I challenge you to think about, in your time in water management, how things have actually changed on the ground. Has the watershed changed? Have your towns grown? And what have you implemented that's going to reduce our impact on the river? I have to say that not a lot of my work has actually led to implementation on the ground. The information is there, but that actual changing of what we see in our watershed when I go out there is small. So our research and monitoring aspect, we do a lot of land use, land cover mapping to look at some of those risks. We have an upstream monitoring program. We do water quality quantification and characterization, publish lots of reports on that, water quantity, looking at the effects of climate change, and then water use now in the future. How much are we going to use? How much are other people going to be using? How much is going to be in the river? And how is that going to affect aquatic ecosystem health? So essentially what we do is we get a bunch of land use data and we look at what we expect those biggest risks are. So we've talked a lot about what the watershed looks like. We've talked a lot about, you probably have heard a lot about headwaters protection. For these areas where we have a lot of forested landscape in the upper areas, and that's where most of our water comes from, it becomes very, very important to consider that, that's 85% of our water is coming from those areas. So when we're designing or trying to do land management, that's an important thing to consider. Our agricultural area is very centered near just upstream of Edmonton, and that's rapidly disappearing through urban growth. So from a watershed perspective, only 14% of the watershed in the upstream of Edmonton is in agricultural land use. So it's important to consider that it is a largely undisturbed or pristine in terms of land cover, not land use, land cover, of a watershed. We're in a really there's a really good opportunity to start to put things in place to maintain that land cover and that hydrological function such that it doesn't affect water quality or quantity moving forward. But that's up to the individual planners, municipalities, and those people making land use decisions. And we know that municipalities are largely responsible for our land use planning, so those are the key implementers of maintaining that hydrological function, maintaining that cover, and influencing water quality in the North Saskatchewan River. Parks and protected areas can do some things, and we've talked a little bit about, the Newcastle in the south. We're 12% of the watershed is in parks and protected areas, and about 5% outside the national parks. So generally, it's thought from an ecological perspective, once you push your watershed, we're greater than 50% disturbance, you start to not be able to go back in terms of that water quality, particularly for lakes, but the same is true for rivers. So it's a good metric for disturbance. If we took the environmental significant areas, it's just one data layer that says these are significant areas. You can read about how they determine what are significant areas. But if you were in charge and you were going to say, okay, I'm going to protect the North Saskatchewan River in terms of ecological integrity, and you just did the environmental significant areas and natural areas, you'd be in very good shape. So that's something to consider as sort of a metric for maybe where we would want to go if we wanted to protect water quality and quantity in the future. And I know nobody wants to hear that because it's a limit, right? It's a limit to growth, it's a limit to use, but from a scientific perspective, this would be a very good standard to set. We have lots of municipal water treatment plants, wastewater treatment plants. Most of them are sewage lagoons, so you can see about 14 sewage lagoons on this area upstream. Rocky Mountain, House Street Valley, and Devon, continuous dischargers, as well as Edmonton. So these are just all impacts or anthropogenic footprints or quantifications of the watershed, all which feed into our risk assessment. So another example was agricultural land use, manure production, pipelines. All of these add up. So we have 150 operational pipelines. This changes, so we're just summarizing the data, the most recent data for this, crossing rivers, and just under 50 crossing the North Saskatchewan River. In Calgary, there are 4. So that's just an example of the difference in how resources have been spread across this province and how we've extracted them. So the risk to pipeline breaks, that's why it's higher for us from a source water protection perspective. Noting that only 9% of those carry oil well effluent and most carry natural gas. So it all just puts things in perspective. It is an active forest management. We do have active forest management areas and agreements in place, and they all have an impact on the small tributaries and then the larger tributaries, and that's being well quantified by the forestry industry, but it's just another land use. So 36% of the watershed is in an FMA, so depending on how you would operate within those could have an impact. So that's the land use. So from a water quality perspective, quantity perspective, Vanessa talked a little bit when the water comes. It's getting earlier and earlier. In 2013, 2014, now we've had earlier runoffs. We've all been around this February. We saw the early runoff this year. So typically our first melt is right now. This is when you would be out sampling the tributaries, and that's when you get your first melt. It's often variable, but we are seeing it earlier and earlier. Then we get that big peak from the winter melt. So glacier melt, about 2.6% of the annual flow is from glaciers. Most of it's from snow melt. So snow melt and accumulation in those headwater areas. And it just kind of puts it into perspective of where the water comes from and how it's being driven. Again, we talk about what affects water quality in the North Saskatchewan River. It's that land use and natural processes. So someone had asked a question earlier that what determines whether the river is healthy or what is a healthy water quality measure. It really depends on the water body and what the natural state of that water body is. There are some lakes, Lake Isle, that is a very naturally eutrophic lake. Just because you have high algae in that lake doesn't mean that it has poor water quality. It just means that it's a very productive lake. If you looked at phosphorus in the North Saskatchewan River, it's naturally higher than the Bow River. So if you set an arbitrary phosphorus limit of 0.05, it's going to do different things to different rivers depending on their limit. So a healthy watershed and a healthy river is generally within that natural variability that we would expect should there be no anthropogenic input for some of those major parameters, total phosphorus, those sorts of things. For other contaminants that are anthropogenic, there are certain aquatic ecosystem limits. If you put a certain pesticide in the water, it's going to kill fish, and there's a limit at which it doesn't kill fish. So that becomes your idea. So water quality in the NSR is affected by natural processes. So when we talk about non-point source pollution, pollution is when we've altered the landscape such that it increases it by more than you would expect under a natural system. That's when it becomes pollution. Other than that, it's not pollution, it's just a natural system process. Anthropogenic inputs and alteration of the watershed can then lead to point source pollution and non-point source pollution. So it's a really tricky idea that non-point source pollution only becomes pollution when we've affected the watershed in a way that has changed natural water quality, if that makes sense. So again, how do we know if water quality is good? We monitor it, and then we evaluate it. So we can look at some guidelines, some toxicity guidelines, or we can look at some baseline values. A good example is looking at Devon and Pecan. We know that land use is more pristine in the headwaters region. We know that the city of Edmonton has an impact. By comparing water quality, we can see the change in water quality, and that can be attributed to anthropogenic inputs or the footprint of the city of Edmonton. So we use all those sorts of things to again, set those site-specific objectives. The research and monitoring aspect, water quality, we monitor, EPCOR monitors 10 to 12 tributaries. And one of the biggest things that we've been working on is that we've got a $1 million water quality monitoring project that starts in 2018 and goes for 4 years to get a comprehensive understanding of non-point source pollution and quantification in the upper areas. So sampling 10 to 12 tributaries a year, 4 or 5 times a year isn't enough to quantify what those loads are going to be. So we've spent a lot of time to try to get this money, and the province is joining us, the Science and Monitoring Division is joining us to implement that monitoring program so that we finally have a comprehensive, at least for 4 years, sustainably funded program to monitor water quality. Water quantity, we've done a lot of work on water quantity, and I'll just summarize quickly to say that we looked at a 1,000-year record, and in the 1700s, when it was really, really very dry, we were still operating at around 55% of the flow of the North Saskatchewan River, the average flow. And even in those drought years, we would still get about 4 million cubic dams. So that would be, it's on average 7 million. So we're still about operating around 55% of the flow. And so those lowest flow years with the dam augmentation, those big, long drought years, we would still get about 100 cubic meters per second. That's generally a winter flow for the North Saskatchewan River. So that's a bit of a good news story. And then our education and awareness component, we sponsor a lot of organizations that do that for us, including the NSWA. In summary, is to do source water protection, you're involved in every aspect of this diagram, and that includes all the organizations that we'll hear speak today, and that includes collaborating on land use maps, water quality data, all those sorts of things in this sort of integrated way so that we can make sure that we're ensuring that water quality and quantity at our intakes is we know what's going to change and we can adapt to that.